So now we're going to jump into chapter 7, which is all about sampling and, in a way, kind of about external validity as well. This will be the last thing we will cover before you will take an exam 3 on this topic plus the previous 2. So our objectives today in these sets of videos are to review the differences between samples and populations. We did that back in chapter 2. We're going to discuss the difference between biased and unbiased samples and how those are recruited. And more specifically here, we're going to ask you to describe and differentiate between different forms of probability and non-probability sampling. There is a lot of terminology here. There's a lot of names for different kinds of sampling techniques. And so your job is really going to be able to describe them and also identify them. So if you get a research scenario describing how sampling was occurring, that you can recognize the key features and put a name to that kind of sampling strategy that the researchers are doing. Okay, so let's talk about populations and samples once again. You will recall that a population is a defined group of people, usually of a large number. So for instance, we might have a population of all Americans or all Georgians or all GSU students. Some of those are going to be extremely large, millions and millions and millions of people. Others might be thousands and thousands of people. I could also consider a classroom like my Psych 3510 online class as a population. Populations are sometimes described in one of two ways, either as heterogeneous or homogeneous. Heterogeneous means that the population itself is very variable, that the people in the population have a lot of different characteristics. And homogeneous means the opposite. It means the people in the population tend to be similar to one another and less variable. Now, the amount of variability, of course, is all relative, right? Americans are a very heterogeneous group. The students in this online class are more homogeneous than that. This tends to be the case when you get into smaller populations. But psychology majors tend to be of a particular age. They tend to be, at least in this class, from a particular geographic area, and they tend to be female. There's a certain percentage of female to male that we would expect. Whereas if we look at something broader like all Georgians or let's say all GSU students, we're going to get a lot more variability. It's not going to look exactly like the makeup of our class does. It's not good or bad either way. The important thing to be able to do with the population, however, is to recognize whether it is heterogeneous or homogeneous. Now, a sample is a subset of that population for whom we have obtained observations. So in research, what we do is we are going to select a number of people from that population and study them, give them a survey, observe their behavior, whatever it may be. The question, which we have come across before, is why do we measure from a sample rather than the entire population? And the answer to this one is fairly straightforward. The reason is you can never get the whole population. Even when you have smaller samples like this class, I will struggle to get everyone to respond to something. So for instance, at the end of every class, there's an opportunity for you to give me comments about how the class went. You are, relatively speaking, a small population of 70 people. I will not get everyone to respond. I just won't. It just won't happen for a variety of reasons. Not good, not bad. It just will not happen. So even when we say we want to get the entire population, it is impossible even for small populations. So if you extrapolate that out and now talk about this for, I don't know, all Georgians or all GSU students or all Americans or whomever, it really is impossible to do. So the only option we're left with as researchers is to get a sample and then try to make inferences from that sample to the population. Accordingly, the big question or the essential question and why we're talking about sampling is we need to know as researchers, will our sample generalize or apply to the stated explicitly or implicitly population? And really what you get or what you can get when you sample are essentially two different kinds of samples, so-called representative samples and unrepresentative samples. So representative samples, which are often sometimes called unbiased samples, happen when every member of the population has an equally likely chance of being included in the sample. The idea here is if you do it in this way, the sample will reflect the characteristics of the population at large just because it's random, and mathematically that's going to work out 98% of the time. And so what representative means here, which you get through this way of sampling where you get an equally likely chance of being included in the sample, is a sample that does reflect the characteristics of the population. So for instance, if the population is 50% male, 50% female, you would expect your sample to reflect that as well. If your population reflects a certain percentage of people of different kind of races, you would expect your sample to reflect that as well, so on and so forth. And this is important because if you can determine that a sample is representative of the population, and you have sampled in the right way to get that, then we can say there's strong evidence for external validity, meaning what we find in our sample will very likely apply to everyone else in that population. Okay, which is kind of what we're looking for as psychologists. On the other hand, unrepresentative samples or bias samples are when during the sampling process, some members of the population have a better chance of being selected or included in the sample than others. And when this happens, when there's not an equally likely chance for everybody to be a part of the sample, then you run the risk of your sample being unrepresentative or biased in some way. This means that your sample does not accurately reflect some or all of the characteristics of the population. And if this is the case, then we would think that your study and your study results probably has weaker external validity. That is, it would likely not fully generalize to the population, but probably only generalize to the people that were overrepresented in your sample that you studied. And so as I was hinting on the last page, there are varieties of sampling techniques, which we will spend the next few videos going over. But broadly, there are two types. There's called probability or random sampling and non-probability or non-random sampling. Probability sampling happens when you are specifying the probability that each individual has of being in your study. It's that first one where we are talking about in an ideal situation where every member of the population has an equally likely chance to be selected to be in the sample. So that's probability or random sampling. Non-probability or non-random sampling happens when you cannot specify the probability that each individual has of being in your study. That is, there's not an equally likely chance that each member of a population gets selected to be in the sample. So if you think about it this way, probability sampling leads to more representative samples, which ultimately leads to higher external validity. On the other hand, non-probability sampling leads to unrepresentative samples more often than not, leading to weaker external validity for your study. At this point, I want to pause and take a moment to remind you about the other validities in this course. We have talked about other ones: internal validity, construct validity, statistical validity, and external validity. And we've recently focused on external validity here, but it's a reminder that this is just one of them. And when a researcher conducts a study, at the outset, they determine which kind of validity is most important to them. If external validity is important for your research question, then you want to do everything you can to use random sampling, given that you're giving it the highest priority. However, sometimes in research, external validity is not necessarily a priority, in which case you might be more likely to find non-probability sampling and be okay with it. It's important to point out that no study, no single one study, can set the standards or show all kinds of validity in one time. This is certainly a balancing act, and with that balancing act, in any particular study, you can really just focus on one. And so in order to show validity of all of the kinds, it usually takes many, many studies over many years by different labs, this idea of converging operations we've talked about previously. There does tend to be some trends, though, in science between what kind of claims people make, what kind of researchers they do, and how important external validity is. So for frequency claims, which we would get by surveys or observational research, we are trying to say a true fact about typically a large population. 36% of undergraduates have smoked marijuana in the last month. 85% of students report rereading their notes as their number one study strategy. If you want to make a singular claim about a large group of people, then your external validity is going to be a high priority for you typically. You don't want to skimp on that for other ones, because the whole point of the frequency claim and why it would matter is because it applies to a big population. So in this case, you would really want to focus on random or probability sampling. Association claims can sort of be somewhere in the middle. So again, we're dealing with surveys or observational research, but you can choose whether you want external validity to be high or low. So sometimes in a survey, you might just be looking for initial evidence of an association. You're wondering if these two variables are related to one another. In that case, you're probably less worried about external validity and more like construct validity. Are you asking the questions in the right way, and are they related to one another? After you find that initial relationship, then you might engage a second survey that is prioritizing external validity at a higher level. So now that we know we have an association between variable X and variable Y in my sample, now let me use probability sampling to get a larger sample and to see if this exists more broadly in the population. So it does, in association claims, depend a little bit more on what you're looking for. And then finally, with causal claims, which we associate with experimental research, oftentimes external validity is a low priority because the whole goal of experiments is to establish internal validity, that a particular cause or a causal variable affects or changes a dependent variable or an outcome variable. Once again, over many studies later in time, once you've found a solid causal relationship, then researchers might think about prioritizing external validity, but that usually happens after many studies prioritizing internal validity. And here's an example of what I'm talking about. So let's say we want to make a frequency claim about how many people want to go to space. One of the ways we could do this is to put a poll on NASA's X page or Twitter page and see what happens. And we get, in this case, 54,000 votes where 86% of people are saying yes. So it does really seem like people want to go to space. I will point out to you that this is a non-probability sample, right? Because not everybody in the population we want to reference, let's say Americans, follows the NASA account. A very large portion aren't even on X. So this is a non-probability sample. Here is the same question, but from a different survey group. So again, this is asking Americans, would they be interested in going to space? And you can see that 58% are saying definitely, probably not, and 42% are saying definitely, probably interested. And you can see the reasons here that they pose. But it's interesting that we get the exact opposite result from a different survey. And so we want to know how data were collected for this survey. And if you dig a little deeper, you will find that Gallup and organizations like this tend to use probability sampling here. So it's a fairly large sample size, not as large as the Twitter poll, but more importantly, they are using a probability method here where they are randomly drawing a survey from landlines and cell phone random digital dials. And so they're basically, dialing random numbers and seeing who picks up and answers. So that is a much more non-probability or random way to sample. And so it's probably more representative. This sample is more representative of the population. And therefore, even though the number of respondents isn't as high, I would put more belief in this one relative to the Twitter one, because the sampling methods here were random and therefore we're prioritizing external validity. And so the sample represents the population more. And so we can feel more confident saying from this sample, here's what we believe is true in the population.